Hello everyone, this is Javeri Ahmed, roll number 2022 CE10 computer engineering student at UT Lahore. So today we will discuss the 11th lecture, which is architecture part 2 of CS 5150. Here we will see different types of architectures including the basic architecture, then we will see the three-tier architecture, then we will see its different styles and internal complexities, then we will see the model view controller, which is very known uh, architecture style these days, and we will see the component diagram of it as well, and then features of MVC. Then we will see the other type of architecture styles like microservices and etc. So let's have a look at the lecture deeply. Here we have lecture goals, which include identify common architecture styles, including three-tier architecture, model view controller, encapsulate deployments using virtualization. Here we will also see deployment using virtualization, where we use basically the virtual machines and then the containers and serverless programming. Architecture styles, we have three-tier architecture style. Here, this is basically the basic website client server architecture style. Here we have a web browser which is on the client side. Then there is a dependency of HTTP. This is an interface, and this is the realization or like the okay. So if you remember in 16th lecture we learned about the okay in the 16th chapter we will learn about realization, which is basically the interface. So this is basically web server's interface HTTP, and web server is basically from the server side, and this is for the client side. So this is the basically the basic website layout that was used. Now we have extension data store. So now there's an extension. Here client side is this one, web browser, and there is a server browser, web server, and then the data from this web server is uh, stored separately. So like if you have stored your so like if you have apps where which store the login data and also the profile picture, then this data will be stored in this database or something rather than on the web server. So this is basically the extension which includes data storage separately. Then there is a poll. Then we have component diagram for the thing that we have already seen, which is basically the extension and data store. This is web browser, this is HTTP, which is its interface, and this is also dependent on uh, this OBDC, which is basically the interface for this database server. OBDC is basically Python library as well, or but it actually is used to interact with this database. So when there is a request, the web server takes the data from the database server and then completes the request. These components might be located on a single node as well. Okay, so any web browser can access the website. Database can be replaced by another that supports same interface. So like you can also change the like you can also bring something else in place of database which supports the same interface. Then we have three-tier architecture style, which includes presentation tier, then we have application tier, and then we have database tier. We also have external services as dependency here. Presentation tier may house internal complexity, but as long as it supports the same interface, it is a binary replaceable component. Now we have presentation tier. This is basically the thing that I was talking to you, that I told you. So this is basically the web browser, and this is the dependency uh, like okay, please let me tell you, this is basically presentation tier complexity. This is a presentation tier, and this is basically the web browser as we see in earlier slides, and this is basically HTTP, which is an interface for application tier, and this is it has dependency on this HTTP. Now here we have HTML render, which includes both JavaScript and HTTP. Each package contains several classes. Okay, they both basically have several classes, and they are making the web browser. So may house internal complexity. There, it can have internal complexity, but as long as it supports the same interface, as long as it supports this type of interface, so it is like binary replaceable component. We can change it with some other as well, but it must be but it must support the same interface like HTTP. Now we have model view controller. Beware many variations. Some are architecture styles. System level responsibilities partitioned into different components. So basically there can be many variations as well. So they can make some problems. Here in the component diagram we have model, and then we have view, and then we have controller, and this is basically the external services. So view controller, they both, all of them have access to each other, but okay. So the current state is handled by controller but is safe in this model. So the view can also take the state query. State is basically sorry query. Sorry, state is basically the current state of view. So view can also take the current state by using the state query, and controller is basically changing the state. So it can change the state in the model of this view. Features of MVC: separated presentation, decouple model and view. Model, like the state is saved separately and the view is separate. Multiple views supported, possibly simultaneous. This is basically an example. A vehicle is flown by a pilot interfacing with a computer terminal on the ground. Okay. Vehicle is basically an automatic, so we can also it can also fly with the pilot who is basically on the ground. Vehicle communicates with ground station via radio signals, as we have seen that it is the automatic, so it can communicate with the ground station using radio signals. These are basically the terms that we learned in computer as well, but this is actuation actu equation. Sorry, no, my pronunciation may be wrong, but this is basically uplink that the station or the a computer terminal on the ground is basically uh, sending the signals on the to the vehicle, and it is basically downlinking or giving the data to it. This is basically by sensor measurements. Example view. Graphical user interface shows model properties as an instrument dials and provides input widgets for commanding actuators. So this is basically pilot, and this has this these kind of controllers. Okay, and this is basically the interface. Model maintains record of the state of vehicle. As I told you earlier, that it will have the state of that vehicle, that whether it about its speed, fuel, etc. Computers derived properties of vehicle, computes derived properties, etc. provides view with information to be displayed to the user. Okay, so the user can also see its current state. Different vehicles will need different models, but might not require new views or controllers. Okay, so here, what is the scenario for controller? View sends message to controller. Case set flaps 220. The controller sends radio command to vehicle. Okay, it basically controls it. Vehicle acts on command. So basically, okay, vehicle acts on commands and replies to controller. Relays telemetry to model. Basically, it gives the state to the model. Model updates state and Model updates state and recomputes stall speed. Okay, and then model identifies view of the new state, and then view displays new state in user interface. What is user interface? This is basically the user interface. Then we have view. We have already told you this. Okay, but we can also see it again. Typically describes to model for notification or state changes observer pattern. Observer pattern is basically discussed in the 16th lecture, and I guess I have also shared the video for 16 lecture as well. So you can just check it on my page, on my channel. Then responsible for rendering to a particular interface, drawing graphics, generating HTML, etc. Sends users input to controller. Okay, user the basic purpose of view is to send user input to the controller, and control will actually manage it, and the model will and control after changing the state will notify model, and model will actually save the state and also notify view about its current state. This is basically all about model view controller, publish, subscribe. There we have event driven control, very loose coupling. Components communicate via message broker, easy to extend. So yes, these are basically its benefits. Virtualization. Now we have deployment concerns. Okay, so now dependency conflicts, configuration, data sprawl, OS probability, portability, unintended interactions. They are basically the deployment concerns which we have to see when we are deploying our app. In virtual machines, we can use virtual machines to bring virtualization. Multiple OS instances running on one machine. This is basically virtualization. We learned about it in more detail in OS lectures. I will, uh, if I get some time, I will also make a playlist on OS as well. Stateful still risks data sprawl over high overhead, software redundancy. Why software redundancy? Because in virtualization, we are basically doing the thing that they are okay. So OS instances, multiple OS instances running on one machine. This is how a user can see it. But when we learn OS, so it is basically context switching. And okay, so but these things basically will be learned or learned in the OS lecture. System configuration management, automate deployments, installing dependencies, configuration, OS, etc. Containers, we have containers. Why we use containers? Because they provide different uh, interfaces for each single application with each container. So what it basically do, often encapsulate a single application. A single container has a single application, often treated as stateless. Don't write to file system. It is stateless because it don't need to be written on the file system. Docker is a main example of it. Serverless computation nodes are stateless. Stateless means we don't need to write them on the file system. Ephemeral and event triggered. Data store services still persist state but are application agnostic. Uh, Application decomposed into event handler functions, event dispatch, container lifetime managed by platform. Now, examples we have Amazon Lambda, which is basically used for serverless computing. So this is all from this lecture. If you have any questions or queries, you can ask in the comment section. Thank you.